Okay, my friends, this is going to be one of several videos about the disaster we're having on the Earth right now with the pushing through the quantum foam of space is moving our weather patterns like crazy because our expansion gases have grown so big that it's so scrubby that it's actually pushing the pole and it's overheating our atmosphere exponentially, and it's moving weather patterns because of this push to all of the surrounding particles in our atmosphere as we spin and get ripped through the particles of space. Space is 100% loaded with particles. It's called quantum foam. Okay, so what is the quantum foam? All right, Fermilab says there's a quantum foam just saturates the universe, and I agree with that. It is light. Light is what's coming off of the sun and all of the luminous bodies, and that is nothing more than laser light, and it's impacting with all of the particles that are in the air in front of it, which are also magnetic particles. So they're being pushed and shoved by a magnetic wave, and they're pushing and shoving back. This is a Venturi, and we have accelerated, it appears, that light. Now, they say that's impossible. Well, it looks like it's possible to me, but anyway, at that point, it seems to have an extreme increase in energy, and they actually separate the particles. And it is a particle, and that is the particle right there. Okay, those are the particles. Now, as they concuss and go through the air, dust off of that, dusty area here. Now, as they go through the air, they impact with what's in front of them, obviously, which is all of those gases. And what happens when they hit those gases, those little tiny particles all over the place here? They charge up. They literally charge up. All right? And they charge those little white particles, and I'll show you that happening. So don't forget, here's what I claim. That is laser light, pulsed red laser, impacting with all the particles that are in the atmosphere. And those same particles will be in space, only they'll be a lot less condensed because they're in the gravitational pull of Earth here. This is that particle that I showed you right there, the particle. That particle has accelerated and hit that Venturi and separated the black ball from the white ball. And here is that actually occurring in real time. And that is pretty much what CERN and Fermilab and all of them have been looking for, is to create this, which is nothing more than this right here. They see these, a black ball and a white ball attached. You saw them before, I showed them to you. There's two of them back to back make a photon. See, when they concuss, we have them completely dividing into little bits and pieces. The sterile neutrons, neutrinos, which are these, they just stay like that. They don't change. They come in just like this. These come in together. This one takes off on its own and doesn't change. It's a fixed particle. Don Lincoln says it's a fixed particle. I agree. This one comes in as the electron neutrino, and instead of being just going on its way, it turns into a shower, and there it is right there. So this is what Fermilab and CERN and all of them want to see. We did it. We just used light. We didn't use huge protons, so we could see precisely what was happening. Actually, the light accelerating, the light showing itself as the black and white particles, and the light dividing here, and the light coming back together here. That's fission, which means to break apart, that's fusion. Now, the only reason that we understand this is that all matter is made of tiny, tiny particles, which is one of these blacks and one of these whites, just like that. Everything's made out of that. Now, how you add them together determines what kind of an atom it is and what kind of a molecule it is. Is it light? Is it electricity? Is it oxygen? Is it hydrogen? What is it? The bigger the ball of particles, the bigger the actual atom. All right, and they just get bigger and bigger and bigger balls. And the dark part, which is that black ball, is so attractive that even when it gets in the mass of a ball like this, it still wants to attract more of the white particles. So they'll come up close in a quantum distance. They'll be just like this. a little one will come up and he'll say, I want to come in here to get to that black one. He'll say, no, you have to stay outside in a quantum distance. Depending upon how many there is here, depends on how many there will be in the layers out here that will surround it. All right, they can't get to the core. They have to stay out here. So this is actually what light looks like in the real world. So it is a particle. They're coming from the sun. They're coming from every luminous source. So it is no question that they saturate the fabric of space, as Don Lincoln from Fermilab agrees. And he also agrees exactly the particles I show here are the particles that he claims exist, the fixed particle and the point particle. All right, you saw them coming through the air like this. What you didn't see is this. This one's glowing because it's the forward leading one concussing with all the particles that are in front of it, so it makes it glow bigger. This was the trailing one hiding behind the dark matter, so it doesn't impact at all, basically, and it just gets very diminished. As this gets so filled up, it will flip, and it will come to the back, and that one will come to the front, and that's called up and down spin, and that's the muon wobble, they call it, and muons, which these are the muons right here, the black ones. These are electron neutrinos, muon neutrinos, electron neutrinos. Muons is what they've been looking for, and as far as I know, they've never actually, they've drawn pictures of them, but I don't think they can find them. We can create them on demand and just squirt them right into the place we want to squirt them into. Actually, we squirt the electron showers, but the muons are just everywhere surrounding that electron shower field. Okay, this is Fermilab's depiction of the fixed particle, which I agree with 100%, no question whatsoever. However, I don't agree with this, that it can be different sizes. I believe there's only one size, and it never changes, and that's this size right here. And I have them in green, I have them in red, we have them in blue. They're all the same particle, they're all the same size. This is a different story. They can go like this, yes, absolutely, I agree with that. So I agree with Don Lincoln and Fermilab on the point particle specifically, but the fixed particle is fixed. It's not, it can't get bigger or smaller. All right, one last picture. We know that they're coming in like this, and then this goes on its way, and this one creates the showers. Now, what happened to this one that went on its way? It can't get through our Venturi. The only reason it went on its own way is because we forced this through a Venturi, which is an angle like V-shaped more or less, only it was curved. And the tiny slit is so small, these black balls, which are all the same size. You see them? They're all the same size. And they're solid. They don't go anywhere, but they're just exactly the same size. Now, the white ones can squish through here because that slit is so tiny that the black ones can't get through. And what they do is they end up being a jackhammer. Boom, 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 boom. Laser pulsed. Bam, bam, bam. They can't get through, but they could squirt those through. And that's what squirts this out of here like crazy. And that's what causes all this. And then, of course, they recombine out here. You see, they're zip right there. They start to recombine. And none of them get through. None. Zero. Nada. None whatsoever get through. So we can point this, and I believe if we could point that into something like this, into a solar collector, we're golden, free energy, because the increase in value of that energetical particle is staggering, absolutely staggering. Before it divided, it was basically a dark particle. There was no energetic value here to speak of at all, way back here, almost nothing. You see this? Way back here, we got almost zip. Over here, we got, this is literally, and I'm not kidding you, this is an atomic explosion on a desktop, only it is in the subatomic region. It is in the light photonic region. This is division, which is fission, and this is fusion. That is atomic energy. And this, my friends, should be 207 times more powerful than that particle was back here. If that's the case, and we put a solar collector right there, a very simple solar collector using this new technology, which is thin film metals. I've been watching this for a few years now, and they're really starting to come on strong. This will absorb most of that energetic value and just turn it into electricity, which means free electricity. And all of these things exist today. There's nothing here that doesn't exist. They're off the shelf today. And I would say, with some serious work, in 30 days, we would know one way or other. Is that an increase in energy from here? I would say it is. And if it's an increase in energy from here, we did nothing whatsoever to increase that energy. The only thing we did was feed it through a crushing Venturi. So we added no additional energy whatsoever, zero. It came out of here, let's say we use 5 watts. Here it should be 200 times that approximately. That should be 1,000 watts. If we started with 5 and we got 1,000 over here, well, we got a hell of a lot of extra energy. And this is tiny, tiny, tiny stuff creating this huge amounts of energy. Now, as I'm saying, I believe in 30 days we'd know one way or the other if we really push on this. If it's wrong, it's wrong. We've been wrong forever on this. It's not like we're doing something different. We're just doing something wrong more. If this is wrong, that's too bad. If it's right, it's pretty good. Because if we could have power like this, you could carry it around in a little shoebox. Here's what I use. Oh, this is a Geiger counter. But it shouldn't be any bigger than something like this. You could actually carry that out into the woods and plug it into something that would, a water pump, to pump water down the mountains and up the hills and fight fires with it and grow food and heat and light and energy and cars and boats and everything. Just this big, you should be able to power a house. If this really does work, the output of energy here is absolutely staggering. And if this is right, the cost of this equipment to make this thing would be just a few dollars, literally a few dollars, to create unlimited free energy. You never have to pull over your car. You'd never have to stop the engines on our airplanes. And you would have no pollution, no chance of runaway power, because this is in a light range, subatomic, but we're still using the same particles they want to get to when they use nuclear energy. But they starting with huge chunks, so they end up with big globs like this flying everywhere. We can only get parts from one of these. That's all we're using is one of those right there. We don't have this splashing all over like machine gun bullets. We have this just breaking apart and coming right back together there. That's not too bad. Okay, I see they're looking for fusion, and this is fission and that is fusion. It's in the subatomic range, but it's still creating this extreme amounts of energy. I believe, I could be wrong, but there hasn't been one penny and one moment invested in interest of this. And this is a working model. Whether it will capture energy here, I don't know. But I see they're spending $1.9 billion. They just invested in some more fusion research. And it's just, they're spewing money at it. And as far as I'm concerned, that's fission, that's fusion. If somebody can argue with that, I'd like to know who it is.